This is a horn enclosure, and it was influenced by this guy, Seshman, another YouTube creator. He claimed to get a 151 decibel reading from two 8-inch subwoofers at 18 hertz. In this video, I'm going to put that claim to the test by building the same enclosure that he built and doing a peer review on the results. We're first going to design, 3D model, and then construct this enclosure before installing it in my vehicle and SPL testing it. Will I be able to replicate the same numbers as Seshman did in his video, or will this design prove to be a complete fail? So sit back, grab you a drink and some snacks, because this is going to be a long one. All right, so what you guys are looking at right now is a screenshot that I took of a rear-loaded horn design by a fellow YouTuber named Seshman. Seshman actually has a video out claiming to achieve a 151 decibel score. This is an SPL score, sound pressure level, using two 8-inch subwoofers. Now, this claim in and of itself wouldn't be that big of a deal if it wasn't at such a low frequency. 18 hertz is what he claimed to have done this at, and it kind of got a few people in our community kind of shook up. You know, it's like, what is this? Is this real? Is this fake or what? So me being who I am, a computer engineer by trade, I decided upon myself to peer review what it is that one of my peers have claimed to have built. So I took the screenshot of the design that he gave us in his video, and I recognize it for what it is. Not only does he have it labeled as what it is, but these are enclosures that I have built for myself. So what I'm going to do is, in this video, I'm going to take that design, I'm going to replicate it as best I can with a screenshot by dropping it into SketchUp and building the panels out panel for panel. The diagram is actually, or it's a two-dimensional photo of a three-dimensional object. And a three-dimensional object, as we all know, have three different planes. You have the X and Y axis, and you also have the Z axis for depth. But the only thing I had to go for or go off of in terms of, perfect measurements were the cutouts. I know that he's using the Z8s from Sundown Audio, so I took those cutout measurements and I plugged them into SketchUp and resized the whole photo based upon that measurement. Now this is a vertical measurement, meaning that I only have the Y-axis for accuracy. And when I did that, I got the height of the panels, but by them being, like I say, a two-dimensional photo of a three-dimensional object, it was a bit difficult to get accurate measurements of those diagonal panels. So I just had to kind of work off a whim based upon that one measurement of that one Y-axis. So the Z and X axis was kind of left up to chance. And once I got finished with it, it looked a little bit like this. And I was a bit pleased with it because it did look very much akin to what he had displayed to us in the video. And I moved on from there and went straight to wood selection. Right now, what you guys are looking at is a 3D rendering of the trunk space of my 2018 Chevy Impala. I just wanted to kind of like reference the size, dimension, and the direction in which this enclosure is going to be facing. He had his facing the front, and I'm going to have mine facing the front. Once again, this is a side firing enclosure. Right now, the blue shade on the screen represents the entire trunk space of the 2018 Chevy Impala. This is approximately 19 cubic foot for anyone who was wondering about that. Moving on, we have the enclosure itself. Yes, this is a huge enclosure. This is for two 8-inch Rampage series subwoofers. And that's by B2 Audio, of course. Very powerful subwoofers. They are 1,000 watts a piece, but though they've been known to do way more than that. Just wanted to give you guys that side profile, that you know this is going to be the exit of the port itself. But let's look at this and let me explain what you guys are looking at. This is the loading chamber for this horn enclosure. So me saying port is actually not correct. You can look at it like a regular ported enclosure, like this would be the loading chamber with a horn attached to the front of it, or a wave guide on the front of it. Moving on, you guys see another blue shading here on the screen, and this blue shading is going to actually represent the total volume of the enclosure itself. The total volume of the enclosure is 8.6 cubic foot. That's the external measurements of it, which has a trunk displacement of 50%. Yes, this enclosure for two 8-inch subwoofers take up half of my available trunk space. And just in case you guys was wondering about a little bit more about the design of this rear loaded horn here has a loading chamber. And the loading chamber's net volume is represented by the blue shading on the screen, and the horn length is the horn displacement itself is represented by yellow. The net volume of the loading chamber is 1.5 cubic foot. That's after displacement. As you guys can see, this has been accounted for. The displacement of the subwoofers have been carved out of this blue material here, and therefore giving you an accurate representation of what the subwoofers themselves are going to have to work with. In this case, once again, 1.5 cubic foot. The line length of the horn is 119 inches, and the horn displacement is 4.8 cubic foot. Let's let that sink in. That's 4.8 cubic foot just for the horn itself, okay? And that's very important. I'm gonna let you know why in a minute. In case you guys are wondering, the throat, or where the line begins, it has an area of 21 square inches. That's 12 inches by, I believe, 1.75. And the mouth, or the opening that you're looking at right here, where the sound exits at, or where someone would probably look at and call a side firing port, has an area of 114 square inches. That gives a 1:5 ratio between the throat, which is the beginning of the horn, and the mouth, which is where the sound exits. Just in case you guys was wondering a little bit more about the construction and dimensions of the horn itself. I chose to go with MDF for this build because, in my opinion, MDF has a superior sound signature when it comes to sound quality. And in this case, I wanted to go with something that was gonna give me the more correct representation of the sound that this horn is producing in and of itself. I don't like plywood because plywood has a particular resonance to it. So I decided to go with MDF. Right now what you guys are looking at is the importance of clamping. Whenever you have this many folds inside your enclosure, you definitely want to make sure you get things accurate. Clamping, you can never have too many of them. And right now what you see me using on the screen right now are foam blocks. I've taken these blocks and I've cut them to a particular length, because what I've decided to do is, instead of cutting angles in the wood like you're supposed to do, I just connected everything as it was, glued them up, put some brad nails in there, and I let the glue get tacky enough for me to be able to actually use the pieces of foam to force them and keep them open to whatever measurement that they needed to be open as the line progressed onward. And it seemed to work out just fine. Just make sure you use plenty of glue. And if you have some very extreme angles, you may want to use caulking. So that's what I did. I glued up the top like you're seeing right now. I let the glue get very tacky before I did this, because I wanted my tight bond 2 to be as thick and tacky as possible to eliminate as much drip. And as you guys can see right here, I didn't get a whole lot of drip. You got squeeze out, which is good, but you don't want all your glue running down the sides of your enclosure. So the best way to combat that is to, like I said, just let the glue sit for a while until it becomes almost like clay, and then attach your boards and you won't get all that squeeze out. But anyway, I flipped the box, allowed gravity to work in my favor, and then I added extra glue to any of those joints that I forced open, or any of the pieces that didn't seem to mate very well to me. I did that for both top and bottom. I went ahead and fashioned a top to this. I added the baffle, cut out the baffle, going to be using that as a template to flush trim a cutout for the second baffle. So this is double baffle. This is going to be a 1/2" drill bit that I'm going to be using from my Milwaukee set. This is the Shockwave set, in case anyone was wondering about that. And then I'm going to be taking this flush trim bit right here from 5 pairs, and then I'm going to be flush trimming, cutting my hole out with this guy. So this makes, I mean, for years I've done it with a jig. I have some drill bits also with my trim router, but the bits are not long enough to go through 2 pieces of MDF. And to get the most accurate measurement, I've just learned to use a flush trim router bit in order to, you know, make sure that your cutouts are exact and you don't have to do much sanding and all that stuff later on down the road. So to keep dust down, just pull out the shop vac and get to work. And, you know, later on, test your fitment, make sure everything is right. These holes cutouts right here are a little bit bigger than 7 1/4. They are actually 7.27. So go up a notch if you have this trim, this Jasper jig that I have. Don't do 7 1/4. They will not fit. You have to go up a notch. So whatever that next dimension is, use that. And as you guys can see, they drop right in. All right, so I'm getting these installed, and you see I already, you know, made the holes and everything. I got this one in, but before I get ahead of myself, I wanted to come along and bring you guys in on the wiring. So these, of course, is a dual subwoofer setup. These are dual 1 ohm subwoofers, okay? This is gonna be what is considered a series parallel wiring configuration, meaning the subs are gonna be wired in series, bringing their impedance load up to 2 ohms each. That's literally negative to positive, each one of them. Negative wire to positive terminal, negative terminal. So they're gonna give me an available positive and negative. If I was to connect this to the amplifier right now, this single subwoofer, if I was to connect that positive and that free negative to the amplifier, it would see a 2 ohms impedance load. All right, but that's not what we want. Our amplifier is actually stable down to 1/2 ohm, and with these subwoofers, we can actually get down to a 1/4 ohm, but it's not stable there. It's stable down to 1/2 ohm. So what we want to do is give it a 1 ohm load. We're going to go up a notch, give it a 1 ohm load. Okay, so series give you 2 subwoofers that are 2 ohms apiece. Then we're going to connect the available positive and negatives to each other. So this positive is going to go to this positive. That negative, that free negative, is going to go to this negative. And that's going to give us a parallel configuration. And you're going to divide these two. So 2 divided by 2 is what? 1 ohm. That's what the amplifier is going to see. It's going to see a 1 ohm load. And the way you do that is, I'll show you this here. The wire is going to run from this free positive and this free negative. And this negative is going to connect here to that negative. This positive here is going to connect to this positive, right? And then you're going to send an additional wire out, positive and negative, to the amplifier. And that's going to give you 1 ohm load. All right, guys, as you can see, we're in the Impala, and right now we're getting ready to test that. I don't even know what to call this. I think this is going to be one of the most interesting builds I've ever done. This, for everyone who skipped to the end of the video, this is a rear-loaded horn enclosure, and it has 2 B2 Audio Rampage 8s on the inside of it. All right, this here does have a loading chamber, which in the past we haven't done that, but this time we did. We put a loading chamber on this thing. Hopefully it'll help out with a little bit more compression and give us a little bit more cone control as we do our SPL tests. And yeah, we're gonna see exactly where this thing peak at. It has 2 peaks when I tested it in-house. It had a peak at around 53 hertz and it had a peak at around 38 hertz. But of course your environment is gonna change that. So that's what we're testing today, to see exactly how loud this thing can get and at what power it can get that loudness. To measure that, we're going to be using the mini bass meter by SPL Labs. This right here is a SPL meter. It measures the loudness inside of your vehicle. It picks up the sound pressure level and it displays a value to you in decibels. So whatever you see on the screen is going to be a measurement of decibels. In order to power this beast of an enclosure, I have the Taramp Smart 8 bass. That's an 8,000 watt subwoofer amplifier. And no, we're not going to be sending 8,000 watts through 2 8s. That'll be ridiculous. So hopefully we don't need to do that, especially with a horn enclosure, because they're very, very efficient. And to measure our power level and to run our dynos, we are going to be using the AMM1 by SMD. Steve Mead is a fellow YouTuber and business owner, and he partnered with Demo Engineering in order to get that thing off the ground. And man, does it do good. It does a lot of calculations for you very, very easily and quickly. So here he is right here. I have my Android application. We're going to be doing a bass sweep, and it's going to be from 150 hertz down to 20 hertz. The bass sweep is to actually allow us to get our peak value. So we need to know at what value should we burp this thing at. And this is what the bass sweep is going to give us. During the bass sweep, the meter is going to give us it's going to give us whatever value was the strongest pressure level, and we're going to use that to burp it. All right, so here goes the bass sweep. Let's go. That thing seems to get louder. Okay, so that was 147 watts at 2 ohms of impedance. 2 ohms of impedance. That's weird. I've never had a bass sweep like that before. It seemed to peak in 3 different areas. And then around 20 hertz, it started to get louder. I've never had a bass sweep like that. That was weird. We got 128.3 in the kick, but that's not what we're looking for. That's how loud it got, but we need to see what? Are you kidding me? This is crazy. I was just saying this. Oh shit, I hit my own star. I'm sorry. I'm sorry.
Cancel. Thank you.
Yeah, guys, I swear to God, this ain't this is no funny business. This is no funny business. It seems to get louder the lower the frequency. It was getting louder. Oh my God. Okay, let's run that again. I'm sorry. I've never had this before. Let's run this again, man. I'm gonna do something else too. I'm gonna reset this. Okay. This is weird. This is so weird. Okay, let me adjust the bass sweep. I want to put the bass sweep down at 15 hertz. Instead of stopping at 20 hertz, I do have a subsonic filter on it, but I'm gonna drop it to 15 hertz at 30-second duration. That's what we're gonna do. Let's okay. Ooh, this is crazy. I ain't never had this before. I ain't never had a box that peaked at 20 damn hertz. Are you kidding me? Let's do that again. Let me reset this. Okay, that's reset. That's crazy. Let's do this. That's so crazy. '53 was a peak. Watch how it gets louder. Oh my God. Oh my God. Oh my God. That feels so weird. It feels weird in here. It feels... Okay, we got a 127.8. 127. Let's look at the frequency. We don't care about the power and all that stuff right now. Let's see. 20 freaking hertz, man. I can't believe that. 20 freaking hertz. And to show y'all that my meter is not broke or none of that, I'm gonna play hit 35. Now it's okay, 35 hertz. So I'm just okay, let's stop this. I'm just letting you guys know it's no funny business going on. This damn box. I honestly don't know what to say here other than this is something I've never built anything like this before, because I don't listen to music at 20 hertz. Like, what music is at 20 hertz other than something that's been rebassed, right? So I guess if you're a fan of the rebass, you'll love this Enclosure. But all that being said, you guys seen for yourself, if you got some good headsets, you would have felt or heard that this thing has 3 peaks. It peaks around 50. It's in the high 50s, the high 30s, the low 20s. It's crazy. 3 peaks. So what we're gonna be doing is doing all of them. We're gonna start at 20 hertz, what this thing is calling for, and we're gonna see what the hell can we get at 20 hertz. That is weird. Never had that a day in my life. But hey, enough talk. We're just gonna do it, man. We're going to do it. Let's get the baseline back there, because we want to measure, we want to monitor what's going on, because at 20 hertz, this thing can unload really, really bad, and you can definitely damage something at 20 hertz. So, all right, 20 hertz, here we go, guys. 20 freaking hertz. We gotta keep an eye on it. Oh my God, it look weird. Okay, I think we should do that again and put some more power through it. Ooh, shit. Ooh, shit. Oh my God. 5,140 watts at 1.9 ohms of impedance. 20 hertz. You can't even hear it, bro. You can't even hear it. It's like a feeling in your face. That's a 135.6. What? I didn't even think it was gonna. 135.6. Okay. Definitely gotta let this one down for this one. Somebody told me to open the whole damn door. I don't know about that. I'm scared of the mosquitoes. But let's do this. Let's reset this. Okay. Let's reset this. I ain't even gonna stop. This is a continuous shot for y'all. We're gonna do another 20 hertz. 20 hertz, baby. Ooh, that sound even louder. Oh my God. Oh my God. What? Oh my God, that feels so weird. That feels so weird, man. 3,329 watts at 1.9 ohms of impedance. Let me let my window back up. Ain't no mosquito gonna bite me today. 140, guys. A that's a 139. I'm sorry, I thought it was a 140. A 139. That's basically a 140 at 20 hertz. Oh my God. Hey, we got to try that again. Look at them going all in. Hey, y'all seen the surrounds on them? They were dimpling. I'm gonna reset this, because we're gonna have 3 test scores. To reset it, I wanna see which one's gonna be louder. Let's open the door. Outlaw, baby. Whole damn door open. Ooh, let's get this. This is crazy. All right, let's reset this. And let's get it. God damn, that sounds so weird. 5,542 at 1.9 ohms of impedance. Woo, we doing it today, goddammit. What we got? 138.6 in the kick. Okay, let's get my goddamn door closed. Come here. Guys, I'm gonna tell y'all something. The door open to my ears, it felt like it was way more pressure. It felt louder to me. Maybe because I got this damn thing in the kick. But anyway, I'm not gonna even worry about it. I don't like putting on the dash and glad it blinds me. I don't like it. But anyway, so here we go. This is crazy, guys. I've never in my life seen nothing like this. But our loudest score was the window open. Here in the kick anyway. The loudest score was the window open. So I think what we're gonna do is open that window again and try to flex a 140 out of it. We were so close. We can do it. Come on, guys. This one for the record books. This is for the record books. Budget bass ain't never got this loud at this low of a frequency. We ain't never did this before. Come on. Let's get that reset. Why the hell my phone keep going to sleep? Okay, here we go. Ooh, that sounds so weird. Let's get it. Ooh, shit. 6,359 watts at 1.8 ohms of impedance. 20 freaking hertz, man. It's a weird frequency, but it seems to love it. 139.7. Oh man, we keep, you know what? I'm gonna call it fair, man. I'm gonna call it fair. I'm gonna let my window up. I'm gonna call that fair, man. I'm gonna call that fair. I'm gonna tell you why. I'm gonna tell you why I'm calling that fair. That's a 140, guys. Come on, man. That's a freaking 140. Everybody know that's a 140. I mean, I get it. If we was in the lanes, no, it's not a 140. You're 3 points away. You're 0.3, whatever. That's a freaking 140 at 20 hertz, bro. Let's go ahead and just address the elephant in the room. All right, this box was modeled after an enclosure that was built by a young man in Australia. I think he's from Australia. I don't know this guy personally. I've never talked to him a day in my life. He probably don't know I exist. And he, you know, that's just the way it is. I don't know. He's a stranger to me. But there's been a lot of controversy going on in our little niche community about what is possible with these different builds, what is possible through the science and the engineering that we do here in car audio. And guys, that dude took 2 8s and he put it in a box that is very akin to this. You guys seen the schematics for yourself. I don't have his plans. I don't have, you know, his vehicle. I don't know how his vehicle has been treated, sound deadened, whatever. I don't know. All I know is that guy said that he had a 140. He had his term lab or some kind of measuring device pulled up right there. And he was showing people, I'm getting 150s at 18 hertz, a 150. I'm gonna tell you, when I first seen it, I'm like, man, that's amazing. Like, it's kind of hard to believe, right? But I can't doubt somebody if I've never attempted it myself. If I've never attempted it myself, I can't doubt. That's just the way I think. I'm not talking about nobody else. I'm not knocking what nobody else think and how they think. That's them. They're their own individuals. But it's up to us as engineers in this, you know, in this hobby that we love so much, to kind of think outside the box sometimes. And if you see someone that you disagree with, or maybe you don't wholeheartedly agree with, like I didn't agree with what he posted, 150 at 18 hertz. I'm like, that's kind of, I ain't never seen nobody do that before. But he posted the plans as well, so let me build it. He put the schematics right on the screen. I said, well, let me build that and see if I can get anywhere near it. It's peaking at 20 freaking hertz. But the dude wasn't lying, man. I believe him, because the subwoofers that he had got twice the power of these, maybe 3 times the power of these subwoofers, and 2 or 3 times the throw, the mechanical travel. So if you put that, and he had them inverted. He had them inverted, meaning he was using all of that loading chamber. That dude knows what he's doing. I believe him. I believe he got a 150 with the monstrous subs that he installed inside of that small car. I believe he got a 150 at 18 hertz. I just got a 140, and I'm in an Impala. My trunk is 19 cubes. I don't even know what all the cabin space. My car is almost 50% larger than his. I'm beating a dead horse at this point. Take this video and do whatever you want to do with it. We got some more frequencies attached though. I told y'all I think it's peaking at around 36 to 38 hertz. We're gonna put it on 36 and we're gonna see how much we can get out of this. 36 hertz. God damn. You guys wouldn't believe how much power there was. 628 watts at 5 ohms of impedance. Let's stop this. But man, they unloaded like nobody's business. 137.1. That's a 137.1. I'm gonna reset this. We're gonna try next at 53 hertz. 53 hertz. Back. Did y'all see that? It pushed the box back. That was crazy. 6,088 watts at 2 ohms of impedance. Man, that 53 did it. 137.3. I don't think it changed. I don't think it changed any. It was loud though. That was a weird volume. Let's try it again at 52 hertz. I'm gonna try it again at 52 hertz. All right, 52 hertz. It's the last one and I'm gone. $5,370 watts at 2 ohms of impedance. Let's see what we got. 137.8. That's it. This thing is tuned low. Low. Very, very low. And I've been playing decals. I've been playing everything on it. You see it gives 140s pretty much all the way across. It's a 140 box all the way across from 150 something all the way down to 20 hertz. This thing doing 140s. That's crazy. But anyway. All right, so time for the music demo. This one here is Dylan Sitz Goodie Bags. Anyway, guys, that's it for that. This thing plays everything, and it sounds damn good doing it. Thanks for visiting the channel to help you simplify car audio. It's the Budget Basshead, and I'm out.